So to read this, last week there was 1.75 liters of coffee that was consumed at home. That's the entire statement. So there is nothing else in that sentence that compares it to something else. This is literally a measurement. Okay. In the next sentence, if 12 fluid ounces of coffee contains 85 milligrams. So here again, we've already done this, but here it is in this problem. Here you see 12 fluid ounces of coffee, but after that, it compares it to 85 milligrams of caffeine. And so our amounts, you want to do a little bit of work so that you can kind of dissect the problem. This 1.75 liters of coffee, this is the measurement. This is how much coffee there was. Okay. The other measurement looking values actually go together. The 12 fluid ounces of coffee versus 85 milligrams of caffeine. So this conversion factor, this is volume of coffee, and this compares it to the mass of caffeine. So this is the measurement. This right here is the measurement. This right here is a conversion factor. Then it says how many grams of caffeine. So we want to go from the total volume of coffee, and we want to convert it to the grams of caffeine. So how do we set this up? If you've watched any of the videos that I've posted, or you've looked at the examples that I have worked out and typed up, you will hopefully see the pattern. What always goes first is the measurement, because this is what you're trying to convert. That is the focus of the problem. So you do not begin with the conversion factor. That is not the focus of the problem. It is just a tool to get to the answer. And so we always begin with the measurement. So our measurement is 1.75 liters of coffee. And there are two resources, or three. One of them is your general knowledge. So general knowledge, your equality sheet, and given information. I do not want you to Google a bunch of conversion factors. Okay? I want your first thing that you should use is the information that is on the equality sheet. The reason for that is you need to learn some of these equalities and see how they compare and be able to then use them on the test, because you will not have Google as an option. So the ones that you will see on a test are either the given ones or ones that we used over and over again that I asked you to learn from the equality sheet. So if you look on your equality sheet, you will find there is an equality with liters, and we want to go into what we use, fluid ounces. This is not mass, this is fluid. We want to go into units that we use. And so liters of coffee, in order to go from the volume unit of liters into our system, we have to go to quarts. Okay. Now, this other one is just kitchen knowledge, and since we're doing this together, I'm just going to use what I know about the units that will lead to fluid ounces. But in the kitchen, we use cups and fluid ounces and those kinds of volume. Those are volume units. And so 1 quart, that volume, is the same thing as 2 pints and 1 pint is 2 cups. And I'm not asking you to memorize these. We're just going to use them, and I'm just giving these to you. And I went to cups because I know that in 1 cup there are 8 fluid ounces. Okay. So the reason I wanted to go to fluid ounces is because I wanted to use this 12 fluid ounces of coffee and 85 milligrams of caffeine. And so once I worked my way to fluid ounces so that I could use this right here. So I'm going to use the 12 fluid ounces of coffee and the 85 milligrams of caffeine. And I need to arrange it so that 12 fluid ounces of coffee cancels. So I'm going to put the 12 fluid ounces on the bottom. And that's of the coffee. And on top, I'm going to put 85 milligrams of caffeine. And I'm putting the description because this actually is allowing us to switch from talking about the volume of the mixture, and it allows us to go to the mass of caffeine. This is not density because caffeine and coffee are not the same thing. It's mixture. And so this is the volume of the whole mixture, and this is the mass of one of the things in it. So fluid ounces cancels, but also the word coffee. I wrote coffee way over here. The word coffee cancels. So a word can cancel, and if you're trying to talk about a piece of a mixture, at some point you're going to have to line up the mixture information to cause it to cross out and allow you to start looking at one of the things in the mixture. So the answer needs to be grams, though. This is milligrams. And so on the sheet is just the metric conversion. On the equality sheet is the metric conversion between milligrams and grams. So this is not you just make up a bunch of new conversion factors. You try to incorporate ones that you are given. This is the fluid ounces and 85 milligrams. And so I used unit equalities to get to the right unit. And then I was able to use this nutrition information about caffeine. And that allows us to get to mass of caffeine. And so according to the definition, 1,000 milligrams is the same thing as 1 gram. And so the unit of milligrams will cancel. So the math, once the unit matches grams, I want grams of caffeine, and I've crossed out every unit by lining them up, and that leaves me with grams of caffeine. Once that matches, that's when you want to worry about doing the calculator stuff. And so you go back to the very beginning, and you want to begin the calculation with the 1.75. So don't start the calculation part of the way through it. The measurement is what you're trying to convert. So it goes into the calculator first, 1.75. And then on top is a 1.0567 to get it to quarts. So we're going to multiply by that. And then it's going to be times 2, because that's on top also. And then there's another 2, so it's times 2. And then next there's an 8, and that's on top, so it's times 8. And then next there's an 85 on top, so it's times 85. And in the denominator there's a 12, so I need to divide by 12. So I'm going to divide by 12. And then the next conversion factor, there's a 1 on top and 1,000 on the bottom, so I'm going to divide by 1,000. You can string the numbers on the calculator, but before you type any number, you've got to tell the calculator, is it in the denominator that's divided by, or is it in the numerator that's multiplied by? So I put divided by 12 because it's in the denominator, but the 1,000 is also in the denominator, so I've got to hit divided by 1,000. Okay, then we get 0.419157667. So that is our calculator number. I'm going to write it on this little strip of paper. Okay, that is the calculator answer. That will not be the right answer. You have to round it. And so this brings in the significant figures. So at the end, you are going to go back to your original measurement, the 1.75, and count the significant figures. So it is the first non-zero, and then there's a decimal, so it is the last number. So that will be 3 significant figures. You use that number of significant figures. That's the information. You only have 3 digits that you can keep. And so we got lots of digits here. And so you go to the first non-zero, which is this 4. That is your first significant figure. Then you count over to the third digit, which is that 9. So we keep the leading 0. We keep the decimal. That 4 is in the 10th place, so it has to stay in the 10th place. And then that 1 and 9, stay 1 and 9 because we're not going to round up. So it'll be 1, 9, and then the unit is not milligrams, it's grams. Grams of caffeine.